In working towards factoring quadratic expressions that have an a value not equal to 1, we're going to look at factoring by grouping. This is another method that we use to factor complex expressions with 4 or more terms. So sometimes we can arrange the number of terms that are given into smaller groups that can be factored by considering common factors of individual groups of terms. The method is as follows. Step 1. So if possible, we group together 2 terms that share the same common factor. Step 2. Factor out the common factor of the grouped items and see if you can find another common factor between the groups, or if there's a special factoring case, such as difference of squares or a perfect square trinomial. Then repeat the process until no more factoring can be done. Step 3. If grouping 2 terms together isn't possible, you can try grouping 3 terms and see if one of the special factoring cases shows up again, and repeat until no more factoring can be done. And then, as with all our factoring problems, you want to check your answer by expanding your final result to make sure that it can be expanded to restore your original expression. So let's apply this method using some examples. In the first example, we can see that we have x times y plus 4x plus 3y plus 12. There's nothing we can do to factor this entire expression as a whole, as there is no common factor between all 4 of the terms. But if we consider groupings, so the first 2 terms as well as the last 2 terms, each of these have a common factor. The common factor of the first group of terms is x, and we can factor it to get y plus 4 remaining. In the second group, we have a common factor of 3, and we end up with y plus 4 remaining. So sometimes after you've common factored the individual terms, you don't always end up with another common factor, but here we can see that we end up with y plus 4 and y plus 4 again. Therefore, we are able to factor out a common factor of y plus 4 out of the entire expression, and we're left with y plus 3. Therefore, xy plus 4x plus 3y plus 12 factors into y plus 4 multiplied by x plus 3. So pause your video and try the next 3 practice problems by grouping and common factoring. Notice in all the given examples that the order of the terms has been convenient to identify the groupings that will allow us to common factor. But remember that you're able to move the terms when you're adding and subtracting different terms in a polynomial. You can reorder them as long as you associate the negative sign with the term that is negative. By moving the terms, you can explore different pairings that will allow us to group the factors. For example, with the third example, if we were to write this expression in a different order as x squared plus 3x minus bx minus 3b, we can again group the terms and common factor in each of those groupings, and we're left with x plus 3 and then minus b, x minus 3, rather x plus 3. Because I factored out a negative sign, this becomes positive. Now we have another common factor of x plus 3, and we're left with x minus b as our other factor. So we end up with the same result, even though we used different groupings. The next type of factoring we'll look at is factoring quadratic trinomials, but when a does not equal 1. Now we want to list the pairs of numbers that multiply to a times c. Given those values that multiply to a times c, we want to find the particular pairing that add to give us b. Now in this step, we rewrite our expression by splitting up our bx value into n times x and n times x. where a times c is equal to m times n, and our b value is the sum of the values m and n. Then we pull out our greatest common factor of the first grouping, pull out our greatest common factor of the second grouping, and factor the greatest common factor out of the entire expression. So just like we did in the factoring by grouping example. Let's do some examples. In the first example, we have 2x squared plus 7x plus 3. From looking at this example, we can identify that a is equal to 2, b is equal to 7, and c is equal to 3. Therefore, a times c is equal to... In step 1, we want to find all pairings of numbers that multiply to 6. And here we have 1 times 6 and 2 times 3. You could consider negative options as well, such as -1 times -6 and -2 times -3, but those numbers will not add to a positive number, and we need them to add to +7, so it's not worth even considering those options. So we look at the sum of these values, we see that they sum to 7 and 5. Therefore, the two numbers that we want to use are 1 and 6, since they add to 7. Now we take the middle term of 7x and we split it up using 1 and 6. So we have 2x squared, and we can rewrite that 7x term as x plus 6x, and we still have plus 3. Now using factoring by grouping, we can factor an x out of the first two terms, and you get 2x plus 1 remaining, and out of the second grouping, 6x plus 3, we can factor out a 3, and we have 2x plus 1 remaining again. Therefore, this factors into 2x plus 1 and x plus 3. Take the time and do a little check to expand out what you factored and make sure that you get the result of what you started with. In the next example, we have 3x squared plus 2xy minus 5y squared. Identifying the values for a, b, and c, we get that a is equal to 3, b is equal to 2, and c is equal to -5. Therefore, ac is equal to -15. Now looking at the numbers, pairs of numbers that multiply to -15, we have 1, -15, -1, and +15, 3 and -5, and -3 and 5. So to multiply to a negative number, you require that one of the two numbers must be negative, but not both. Okay, now calculating the sum of these values, we know that for this problem to work, we need them to sum to the b value, which should be 2. And the sums are -14, +14, -2, and +2. Therefore, the desired values to use are -3 and +5. We can decompose our middle term in our function to have the values -3 and +5. So we write this as 3x squared minus 3xy plus 5xy minus 5y squared. So all you've done is replaced our term bxy with two terms that equal the same value. Okay, now we can group the terms and factor out of each of those groupings. So the first common factor is 3x, and we're left with x minus y. And in the second common factoring, we have a common factor of 5y. So when we factor out 5y, we're left with x minus y. Now we can see in each part of the whole expression, we have a common factor of x minus y. We can factor that out, and we have 3x plus 5y remaining. Now you can expand that all out using the distributive rule and check that it equals your original expression. In our third example, we have 9x squared plus 30x plus 25. We want to find two numbers that multiply to give us a times c. So ac is equal to 9 times 25, which is equal to 225. and we want them to sum to our b value of 30. Because we know that we want the values to sum to positive 30, it means that both of our values that multiply to 225 must be positive. So we only need to consider positive values. We have 1 times 225, 3 times 75, 9 times 25. We should also consider factor of 5, and 45. And last but not least, 15 times 15. So looking at the sum of these values, we get 226, 78, 34, 50, and our desired sum of 30. Now we split up our 30x into 15x plus 15x, and then factor by grouping. In the first grouping, the greatest common factor is 3x, and we're left with 3x plus 5. And in the second grouping, we can factor out 5, and we are left with 3x plus 5. For the greatest common factor is 3x plus 5, and we're left with 3x plus 5 again. If you like, we can express this as 3x plus 5 all squared. And this question is the perfect segue into the next video, which will examine special cases of factoring trinomials, such as the difference of squares and perfect square trinomials. So factoring is often easier if you start to recognize patterns as well as similarities in the expressions. You want to make sure that you really practice these problems so that you can recognize the patterns and similarities. Practice makes perfect.